is we're on a new chapter, chapter 4. I just did a weird symbol. Students can now see my application. What does that mean? Don't know. Anyway, let's look at how to find absolute max and mins. And so here's just a nice cubic to start off with. Essentially, I'm going to go through the same question, but with different functions and different intervals. So I want you to get the idea of the process that I'm using here, so that you can adapt it to all the new different nuances, different situations that are going to happen. So here is our first one. So the first thing that I'm going to do, step 1, is I'm going to find the derivative. In this case, that's not going to involve a great deal of work. But in other questions, that is going to be a fair amount of work. Can you imagine there might be a chain rule or a product rule or, God forbid, a quotient rule, right? And so there'll be a lot of algebra. And also make sure that you do style points on the derivative. It's important that you get it written in the best way possible. And that will be make it look like the original and factor the heck out of it. And if you're unlucky enough to get a trig, look for a trig identity that simplifies it. But normally you're just going to be working on 2 of them. Make it look like the original and factor the heck out of it. I'll keep my fingers crossed I did this right because I was doing it just before the cross game. If you differentiate, you're going to get 6x squared. Take away 12x. Take away 3, although I may change that 3 in a minute to 6. Let's see. I could pull out a 3 and get 2x squared, take away 4x, take away 3. Hold that thought for a minute while I figure out a way to make this work, because I want this to factor. I don't want decimals. I want 4, so a 5 here would be good. 5 here would be 1 and 5. No, I need 3 there. I need 4. How am I going to get 4 out of this? 1.
Isn't it a 1?
It's what a 1?
2x squared minus 4x minus 1.
Oh, minus 1. Oh, good. I don't need to fix it. Thank you. Right, so when I factor it, oh, I may have to fix it. But I will fix it in a minute. I need 2 here, and I need 2 here. I need a 2 here, I need a 3 here, and I need a 2 here. We're going to get that. Darn it in space. Okay. Well, let's put the answer in, and then I'll work backwards to make the question match the answer. That's probably the easiest way of doing it. So I'll make that -1, and I'll make this +3. Right, that's good. And that gets me 5. So I need this to be 5. And the only way this is going to be 5 is this is 15. And the only way you're going to get 15 out of this is if we had 15 halves there. Kind of had to work backwards, but here we go. Imagine that we had started with 2x cubed, take away 15 halves x squared, take away 3x plus 7. If you differentiated it, you would get this guy. If you pull out 3 as a common factor, you get this. And if you factor it, you get this. There. So the questions should be, well, they'll be right straight off the bat. Here I had to tweak it to make it work. We now have a question where we can move on to step 2. We found the derivative and we've made it look as pretty as it can. We now are going to find the critical numbers. Critical numbers are places where the derivative is 0 or where it's undefined. Now, since this is really factored, it's quite easy to find when the derivative is going to be 0. It will be 0 when this factor is equal to nothing, which is -3, or when this factor is equal to 0, and that's going to be a half. 3 doesn't matter. So I right now have 2 of these guys as my critical numbers. What you need to do in step 2 is, after you find the x coordinates of your critical numbers, the places where the derivative is 0, is look at this interval. Are any of these guys no use? We can't use them. Any of these 2 guys not usable, because we're only looking at the interval from -2 to 5.
-3.
You will find that sometimes you have to kill one or more of your possible critical numbers. In this case, I'm killing off -3. So that's step 2 done. Step 1, find the derivative and make it look pretty, style points. Step 2, find the places where the derivative is equal to 0. These are the critical numbers. And once you've found them, look at the interval of interest and destroy any, kill off any that don't fit inside this interval. There is a second part of critical numbers, isn't it? Find when the derivative is undefined, because that's also where critical numbers live. But I don't need to in this case, because I know fine well that that's never going to be undefined. Then we move on to step 3. And in the third and final step, essentially, although there's a bit at the end, create a table of values. You set up a table with the x value and then the value of the function next to it. And your table should always start at -2 and should always finish at 5. And then in the middle, put any critical numbers that you've got. Well, I have a -1/2 and I'm going to finish at 5. So in this case, my table just has 3 values. Now for each one of these 3 values, you find the value of the function and you plug it in here, here, and here. If there's a lot of numbers in your table, or this function is really ugly, there is a way that you can let the calculator take a lot of the work off. So let me show you how you can make the calculator work with this function. So you press y equals, and you type in this case, 2x cubed, take away 15 halves, I'll put a little bracket around it to be sure.
Didn't we say it was +1/2?
I don't know what you said there, Alec. Say it again, please.
Didn't we say it was +1/2 in the table?
Yes, we did. Thank you. So we got that guy. Take away 3x, add 7. That's good. Don't need to worry about the window actually. Hit. Right, so y, type that again. Second table set up. And just go down to the independent variable and go to ask and press enter. And what that's done is it's going to, we're going to set up a way of getting these values. So second table set up, do this, and then you go second table. And now I can type in -2, 1/2, and 5. And do you see how quick it is with the answers? Plus, I know it's accurate as long as I typed it in right. So this guy is -10.5. This guy is -1.75. And this last fella is 234.5. Everything you need to know about the absolute max and min is in this table. So this number here, the 234.5, is the absolute max. So the absolute maximum value of this function is that guy. That's the guy you write in WebAssign. And would you agree that this one is smaller than any of the others? And so this counts as our absolute minimum value. So once you've created your table of values, whatever is the biggest number is your absolute max. Whatever is the smallest number in your list is your absolute min. And it doesn't matter if it happens 2 different places, right? So if there was another negative 10.5 somewhere, this is still the absolute min. And if there was another 2 places at 234.5, this is still the absolute max. So those numbers are the y coordinates, right? These things with the circle around them. That's what we mean by the absolute max and min. But apart from a little wobbly start, are we comfortable with this process? Differentiate style points. Find the critical numbers, kill off any that don't fit. Create a table of values. The biggest answer in the y's is your absolute max. The smallest answer in your y's is your absolute min.
Which number did we enter into the graph?
Into the graph, I typed in the original 2x cubed, take away 15 halves, x. Oh, darn it in space. It's 15 halves x squared. Right. So my numbers are a bit out because of that. But the process is right. I'm going to try another one. Yeah,
I have a question.
can't really leave this guy, it's bugging me. I should have typed in,
I have a question.
yes,
When we're doing these types of problems, are we putting in what the absolute max and minimum are, or are we putting where they occur?
you're putting out what they are. So you're putting in the fx value, right? The y coordinate value.
Okay. Okay, thank you.
So that's the guy I should have done. And if I go back to my table setup, I could delete these guys. I could put in, you know, the -2, 0.5, and can't remember what the other number was off the top of my head, 5. And that's the absolute max now. That would be the real one. That would be the absolute min. So if you wanted
I'm
to-
putting, sorry, I'm
Mhm.
putting in the f prime of x.
no, I'm
Or-
putting in the original untouched function.
Okay, got it.
We're going to see this a couple of times. So even although I'm kind of jumped by that one a little bit, I think by the time we've seen a couple more, will be good. So this is our next one that we're going to find the absolute max and min of. There's our function. We're interested in the range of t from -1 to 3. And first thing I'm going to do is rewrite this like that. Style points is going to get much more difficult in these later questions. This one looks straightforward, but it's going to be a little bit uglier than you might expect. If you differentiate, you get 1. That's the easy one. You multiply by the power, and then you reduce the power by 1. So far, so good. Now, style points. Hopefully you're comfortable with negative powers becoming positive powers. So that guy is now this fellow. That in turn is going to become the cube root of t squared. Are you comfortable with the derivative is now this guy? So far, so good. Right. So that would essentially be my step 1 done. Now, step 2, let's go looking for critical numbers. The first type is when is the derivative 0? So we are going to end up having to solve some really weird equations. There's my first one. That guy there has to equal 0. And it's not a good idea to plug it into Desmos, because all Desmos is going to tell you is that it's, 0.2345 or something. And we need exact values, which is pretty much going to make this much, much uglier to do. So I'm going to use a technique that I use a lot called as long as you do it to both sides, it's okay rule. So the first thing I'm going to do is to add that ugly fraction to both sides. Okay. Now, if I call that 1/1, it might give you a clue to what I'm about to do next. What do you think I'm going to do next? Remember, the goal here is to find t, right? To solve for t. So what am I going to do next?
Cross multiply.
Right. If you cross multiply, you get 3 times the cube root of 2 squared equals 1. If you then divide both sides by 3, you get that. Still with me? Okay, remember the goal. Always keep the goal in mind. When I'm finished, aren't I going to have t equals? What could I do to both sides to get closer to that place?
Cube both sides.
Yeah. And if you cube this guy, can you trust me, you get 1/27. Okay, we're almost there. What do we do to both sides now to find t?
Square root it.
Yeah. Now, square rooting is not going to be fun, yeah, but it is the right thing to do. So technically, isn't there 2 critical numbers? There's this ugly one, and this pretty much just as ugly. You might think, well, can I just leave it like that? Nah, sorry, ain't going to happen. I'm going to have to make these answers look pretty as well. So if you separate this, you get the square root of 1 over the square root of 27. And if you separate this, you're going to get the square root of 1 over the square root of 27, which is fine. The square root of 1 is just 1. 27 can be made nice. Square root of 27 can be turned into something, can't it? 9 times 3, 3 root 3. Looking better? Any suggestions to do some more? You don't like square roots on the bottoms of fractions, do we? So, any suggestions how to fix it?
Multiply by root 3 on the top and the bottom.
Correct. And you get negative root 3 over 3 times 3 is 9, and positive root 3 over 9. God, that was a lot of work, wasn't it? And I should check these two guys and make sure that they are in the range -1 to 3, and they are. So I'm keeping both of them. I'm keeping them because they are somewhere between plus -1 and +3, right? They're in that range. Now, there is a second critical number that's possible. Don't you get critical numbers when the derivative is undefined? Is there any value of t that would make this derivative impossible to calculate?
0.
0. And I don't need to do any clever work on that, can I just say it's 0? Is 0 in this range? Oh, yeah, so that means I can keep that. So we have found, with a lot of heavy duty work, we have found all the critical numbers. So I'm going to move on to step 3, table of values. And I'm putting them in order. So I start with -1, and then I'll put in that -√3/9. Then I'll put in 0. Then I'll put in +√3/9. And then I'll finish with 3. So I got my start number, -1. I've got my finish number, 3. And I've got 3 critical numbers, and I've put them in order. I guess you could just mix them and match them if you felt like it, but to me it makes more sense in that order. I'm now going to put in the original function, which, to remind you what it was t, take away the cube root of t, and I'm going to put it into our calculator and use the table of value trick. So y equals, so it's going to be t, well, I'm going to have to call it x, but it's the same thing, right? X take away, and to get the cube root, there is a cube root function hidden deep inside TI-84s, but it's a pain to get to. So I'm just going to go x to the power of 1/3. Would you agree that's the same thing as a cube root? And okay, I'm using x's instead of t's, but that's no big deal, right? Now I've already set up the table thing, so I don't need to do that anymore, right? If you've done it once, you can leave it alone. So I can just go straight set up table. I'm going to delete old answers, and -1, negative the square root of 3/9, negative the square root of 3 divided by 9. Oops, let me check that. Negative the square root of 3, I should be able to do that, divided by 9. There we go. 0, positive the square root of 3, divided by 9, and a 3. So I have a 0, a 0.3849, a 0, a negative 0.3849, and a 1.5578. And let's see who the absolute minimum is. Would you agree this one here is smaller than anything else? So that's my absolute min. Where's the absolute max in this one? And it's this one. And I'm now going to just tweak the answer a little bit. This guy is the value of the function at 3. So that's 3 take away the cube root of 3. And this one is the value of the function at that fella. So that's going to be √3/9, take away the cube root of √3/9. And allegedly, well, there's your answers. I'm leaving them as decimals. I thought they might come out nice, but they're not really. So there's no point. So you can find a fraction one. Okay. Haven't found a fraction one yet. I did find a chain rule one. So we're being asked to find the absolute max and minimum value of this function on the given interval -3, 5. Chain rule. 3 times t squared take away 9 squared times the derivative of the inside function, which is 2t. And that gets me 6t, t squared take away 9 squared. And that's step 1 done. That one, a lot less work, right? Something's cubed, 3 somethings squared times the derivative of the inside function, which is 2t. Multiply these together, you get 6t, and then leave that. So now I need to find the critical numbers. In this case, I only need to find when is the derivative 0, because just by looking, I can tell you're not going to have undefined. So it's 6t, t squared take away 9 squared is 0. And that one gives me t equals 0. What values of t make t squared minus 9 0? What values of t make t squared minus 9 0?
-3 and 3.
Yes. Do you know the more common mistake that people do is to only find the 3? Because that's the easy one and you forget there's a -3. So are any of those 3 guys a problem? Can I use all of them? Yeah. In fact, isn't that one of the endpoints? So I don't need to worry about that, right? It's that guy. So I should be able to set on my table. Again, it's called t and f of t. Right? And it starts at -3. So that's this one. Check. Then you go 0. Check. Then you go 3. And then you finish with 5. So I can set up my calculator to do that piece of the puzzle. Original function, a bracket, call it x squared, take away 9, close the bracket, raised to power of 3. And then I should go into second table, just hit the delete button, clear out the old stuff. And then type in -3, 0, 0, 3, and 5. And the numbers I got were 0, -729, 0 again, and 4096. And that number there is the absolute max. And that number there is the absolute minimum. Are we comfortable with that question? At the beginning, have a flow to them. You know, find the derivative, make it look pretty. Find all the critical numbers. Set up one of these tables, the biggest answer, absolute max, the smallest answer, absolute min. You might have some problems algebra making this look pretty. You might sometimes have problems getting the critical numbers, you know, like that √3/9 kind of thing, right? You might have some issues, sometimes anyway, with doing that. Any questions? Okay. Let's find a fraction. And I found one at 19. Find the absolute max and min of this function in the range 0.2 to 20. Interesting. Okay, I need to differentiate this fraction function. Right, it's a rational function. Any suggestions for how to rewrite this fraction to make it easier to differentiate?
25x to the negative first.
You nailed it. So when I differentiate it, I can just use the power rule. That gets you 1. Multiply by the power, reduce it by 1, and then do some style points on it. In this case, make it look like the original. So far, so good. I don't need to make that any prettier. It'll do the job. That doesn't look like a derivative. There we go. So let's go hunting for critical numbers now. Just because I want to, let's look for undefined. Is there any value of x where you couldn't calculate this? Because I can see one. What value of x would be impossible to calculate an answer for?
0.
0. Do you see we didn't really need to do any math, right? It was just, you can look at it. Is 0 usable in this interval? No. So although we found it to kill it off because we can't use it. But maybe the next time you do use it, right? So you've got to keep it, in play. Now the next stage is we need to find out when is the derivative is 0. And that means that we have to solve some weird equations. Any suggestions about what I could do next on that one?
Add 25 over x squared to both sides.
Okay. And can you see a cross multiply trick again? In which case you get x squared is 25. And that means x is what, plus or minus 5? And that's two choices. Negative 5 is a choice, plus 5 is a choice. Any of those two a problem? Is there any issue with either of those two? Look at the interval. You can only pick numbers from 0.2 to 5, to 20, I should say. Problem? Can't use them. Why? Negative 5 is out here, right? It's outside the range. And that's stage 2 done. Set up our table. Starting at 0.2, the only number that actually made it was 5 and finished with 20. And the function that we're working with is x plus 25 over x. So I'll go to my calculator, I'll go into y equals, and I will type x plus 25 divided by x. And then I can go to second table, delete the old information, put in 0.2 and get the answer 125.2. Put in 5, get the answer 10, and put in 20 and get the answer 21.25. And looking at this table, that number there is the smallest. So there's the absolute minimum. And this one here is the biggest. And so there is your absolute maximum. And these are the two numbers that you would put in WebAssign. Are we good? Okay with that one? For the time that we've got left, I'd like to start by giving you some practice at ugly things to differentiate and get critical numbers. So we're not going to do the whole process. We are just going to find critical numbers. And here is an example of a really ugly function. It's a version of 14. Now you want to differentiate a square root or a cube root, turn it into a fractional power of 1/3. It's the only way you're going to be able to differentiate a square root or a cube root, make it a fractional power. Now, that makes this a chain rule. It's something in the power of 1/3. So you multiply by the power, then you reduce the power by 1, and then you differentiate with what's in the brackets, right? The inside function, which in this case is -2x. And then you start saying, okay, this thing, this mess, has got to be written down as pretty as it can, right? Style points. So I'm going to have -2x on the top. I'm going to have 3 on the bottom, and I have 81 take away x squared to the positive 2/3. I'm then going to turn that fractional power back into that guy. And although that doesn't look particularly nice, that's as good as that ugly fraction is ever going to be. Okay. Now we need to find our critical numbers. Sometimes, even when it's a really ugly fraction, as this totally is, you can find the critical numbers just by looking. I can look at this ugly fraction, and without any more extra work, I can tell you the value of x is going to make this fraction 0. Can you tell what value of x is going to make this fraction 0?
9.
Oh, I know where 9's coming from, and keep that thought because it is an answer, but it's not the one that's going to make this 0. But keep that answer, it's going to get used later.
0. would make
Yeah.
it 0.
Aren't fractions going to be 0 when the top is 0? So I just need to make x 0. Right, now that 9 you were talking about, I like that 9. But isn't that when the thing is undefined? Because zeros in the bottom are bad news for fractions. And you said 9, which I like, because that is correct. There's another number. We tend to miss the second one, but it is there.
-9.
-9. And now you have found the 3 critical numbers, but that's all you're being asked to do here, right? You're not being asked to build a table, you know, decide which ones can be used or not. None of that's necessary, because in this question, just find the critical numbers. And I believe in the way that they want you to write them down in the little box, you would go -9, 0, and 9. So you just write them with little commas between them and put them in numerical order. Are we good with that one? Right, let's do an uglier fraction one, but again, only focus on critical numbers. So this one is 13. We have g of y. And we're going to differentiate. Which one of the techniques that we've learned over the last 7 weeks do you use when you want to differentiate a fraction like this?
Quotient rule.
That's right. And the top guy is going to be called f, and the bottom guy is going to be called g. And it's going to become f dash g, take away f of g dashed over g squared. And if you differentiate top, you get 1. You leave the bottom alone. Take away, you leave the top alone, and you differentiate this guy. And then the whole thing on the bottom gets squared. So f dash g, take away f g dashed, all over g squared. And then style points kicks in. You try and make it as nice as possible. 1 times this guy doesn't do anything except you write it down again. I'm going to FOIL this out and subtract at the same time. So y times 2y gets me 2y squared, and then I subtract it. Y times this guy is negative 3y, but then I subtract it. Negative 1 times that is negative 2y, but then I subtract it. And negative 1 times that is plus 3, but then I subtract it. So what do I get? I have a negative y squared, that, and a plus 2y, and that kills off that. And that's all I've got left on the top. Right, time to factor the heck out of it. Is there anything you can do to make that fraction just a little bit prettier? Think about factoring. Anything you can do to that ugly mess on the top.
Factor out the y.
Yep. Okay, we should be able to get critical numbers now. Let's find the values that make the derivative 0. When you're dealing with a fraction, zeros will only happen when the top is 0. So you can totally ignore the bottom. And when you look at the top, what values of y make this 0? Well, definitely y equals 0. That's one of the answers. But there is a second one, isn't there?
Y equals 2.
Correct. And that's it. Don't look for any more because it won't be. If you want to find when is a fraction undefined, you look at the bottom and you look for when is this 0. Now, this particular quadratic doesn't factor. I know that for sure. And I can check pretty quickly that it doesn't actually ever equal 0. Can you imagine a quadratic that's always above the x-axis? It never quite gets to 0. That's one of those. So the answer is that there isn't any. So you're finished. There are only 2 critical numbers. If you were really stumped, couldn't you just put that bottom thing into Desmos and see if it cuts the x-axis? And that would tell you if it factors or not. Okay, put your names down. And I think we should finish with a joke today. We've pretty much covered this section, so tomorrow we'll be starting a new section.